Saskatoon Homes is a construction company that builds houses on lots zoned for residential development. The revenue R for these homes is R of Q equals 100,000 Q minus 100 Q squared, where Q is between 1 and 40 and represents the number of homes that can be built in 1 month. The number of homes Q that can be built each month depends on the number of workers W available, where Q is related to W by Q of W equals 1.8 W to the half plus 0.4 W, where W is strictly greater than 0. What is the marginal revenue product, DRDW, earned when 100 workers are hired during a particular month? The revenue earned depends on the quantity of houses sold, which depends on the number of workers available to build them. So R depends on Q, which depends on W. So the derivative of revenue with respect to the quantity times the derivative of the quantity with respect to the number of workers W gives us the marginal revenue product, DRDW. And since we want DRDW, we want the derivative in terms of W. So we replace Q with Q of W. Then when W equals 100, the marginal revenue product is $43,316. An alternative way to motivate the chain rule is through function composition. We can create R of W, giving revenue as a function of W, by composing R of Q with Q of W. By the chain rule, the derivative is R prime of W equals R prime of Q of W times Q prime of W. Actually, this is the same thing as dRdQ times dQ/dW after Q of W is plugged into dRdQ. When W equals 100, R prime of 100 is $43,316. In general, given differentiable functions f and g such that the range of g is contained in the domain of f, then f of g of x prime, the derivative of the composition, equals f prime of g of x times g prime of x. To reinforce this, let's consider the example y equals the square root of x squared minus 6x plus 4. We rewrite the radical as an exponent, so we have y equals x squared minus 6x plus 4 to the half. Then y prime is half x squared minus 6x plus 4 to the negative half times 2x minus 6.